Competitive electron transfer reaction. This is what is the point. Competitive electron transfer reaction. This is 8.21 student. This is the now we are going to understand what is competitive electron transfer. So place a strip of metal zinc in an aqueous solution of the copper nitrate as shown in the figure 8.1. So where they have shown student, here they have shown. This is the figure 8.1. What they are placing a student, zinc rod is placed in the copper nitrate solution. This is what the point. Now let us have a look over it, what they are saying. For about 1 hour you may notice that the stream become coated with the reddish metallic metallic copper, and the blue color of the solutions disappear. Formation of Zn2 plus ion among the products can easily be judged when the blue color of the solution is due to Cu2 plus has disappeared. Okay, so let us see the point by point what the meaning of these students. Okay, here you see. So they are saying that is we have the container student and place a strip of metallic zinc. We are placing the what student, metallic zinc student. This is the Zn in a aqueous solution of copper nitrate. So here what is there student, CuNO3. Now how many hour? For 1 hour. You may be noticed that the strip become coated with the reddish metallic copper. So what is this is being the coat is being covered on this metallic wire. This is the reddish color is being coated now with the reddish metallic copper. The blue color solution disappear. So it was initially it is blue color, it is the blue color student. What color? Blue color. And this is the disappear, color disappear. Okay, color disappear. Why the color is getting disappear? Let us try to understand. The blue color of the solution disappear. Why? Formation of Zn2 plus ion among the products can easily be judged when the blue color of the solution due to Cu2 plus disappeared. So what is ions are being formed here student? Zn2 plus ion. Okay, so because of formation of Zn2 plus, because earlier what are there? Earlier Cu2 plus and NO3 minus is there. Okay, NO3 minus was there. Okay, this will be the copper nitrate. So this was there. Now student, what is happening? If hydrogen sulfide gas is placed through the colorless solution containing Zn2 plus ion, appearance of white zinc sulfide ZnS can be seen on making the solution alkaline with ammonia. Okay, so what the point is student? What the point here? The reaction between the metallic zinc and aqueous solution of copper nitrate can be written like that. So zinc is converting into Zn2 plus and copper 2 plus is converting into copper. In the reaction 8.5, zinc has lost electron to form Zn2 plus and therefore zinc is oxidized eventually. Now if zinc is oxidized, okay, releasing electron, something must be reduced accepting the electron lost by zinc. Copper ion is reduced by gaining electron from the zinc. So what is happening? Zinc is more reactive, so it is losing the electron, reducing the copper 2 plus, so it is forming Zn2 plus and it is forming the copper. This is what the theme of this paragraph. Now you see the reaction 8.15 may be written as how they are writing the reaction 1.85. So Zn solid, copper 2 plus, so it is converting into Zn2 plus and copper solid. This is what the now Zn is releasing the 2 electron and copper is gaining the 2 electron. This is the line. Now you come to the point here student, what the at this stage we maybe investigate the state of equilibrium from the reaction represented by equation 8.15. For this purpose, let us place a strip of metallic copper in a zinc sulfate solution. No visible reaction is noticed and attempt to detect the presence of the copper 2 plus ion by passing H2O gas through the solution to produce the black color cupric sulfide CuS does not succeed. Okay, so cupric sulfide has such a low solubility that this is an extremely sensitive test. At the amount of Cu2 plus form cannot be detected, we thus conclude that the state of equilibrium for the reaction 8.15 greatly favor the products over the reaction. So let's have a look over here. So what is there, student? What is here? So copper 2 plus is there. Where? Because copper nitrate is there in the solution. This is electrolyte. So it will give copper 2 plus 2NO3 minus. And you are treating with what, student? You are treating with the zinc. You are treating with the zinc metal. The solid, this is aqueous. Now what is happening? What is happening? This is equilibrium where they are shifting. And what they are forming, student, Zn2 plus aqueous, and then this is forming copper solid, right? So in the total process, zinc to Zn2 plus, what is happening, student? Zinc to Zn2 plus. So this is either you say loss of electron means oxidation, right? Now the second point, you come to the second point, Cu2 plus to Cu. Okay, Cu2 plus 2, what is forming, student? Cu2 plus 2 Cu. Here what is happening, student? The gain of electron. Here is the addition of electron. Here what is happening? 2 plus is the addition of electron. So this is what is, you can say, reduction. Now if you are treating this one, student, if you are having, just revert the reaction. If you are reversing the reaction, okay, so what you are going to get in this meaning of this paragraph, total paragraph we are trying to understand the meaning of this paragraph. What they are saying, if that is copper is treated with the Zn2 plus, means copper nitrate, so here will be, that is no change, student. This is the, there is the case of no change. So that is what the point. Now let us extend the electron transfer reaction now to copper metal and silver nitrate, this one. Okay, solution in the water and arrange setup of shown the figure 8.2. The solution develop blue color to the formation of Cu2 plus ion on account of reaction. Why this is developing? Because copper is more reactive, because here is copper Ag Au Pt. This is the order. So copper is on the top in the reactivity series. Copper have the upper position than the Ag. So what we are happening, student, here is Cu is treated with Ag. So Cu2 plus and 2Ag is forming. Okay. So here what is happening, here Cu is oxidized to Cu2 plus and Ag plus is reduced to Ag. Equilibrium greatly favored the product Cu2 plus and Ag. Okay. By way of contrast, let us also compare the reaction of metallic cobalt placed in nickel sulfate solution. The reaction that occurred here, what is happening, that is they are also treating, that is cobalt to nickel. So cobalt 2 plus and nickel is forming. So here is the cobalt is releasing electron and nickel is getting electron. So this is what is known as, student, competitive transfer, electron transfer reaction. Here you see, okay, actually this is the direct NCERT book. The color is not that much of appearing. When you are watching this video, you open the NCERT book and then try to understand redox reaction between copper and aqueous solution of silver nitrate and occurring of the color. Okay, so initially this is no color, then slowly color develop, it is complete color. Okay, here you see, student, at equilibrium chemical test reveal that both Ni2 plus and CO2 plus are present at moderate concentration. In this case, neither the reaction CO or Ni2 plus nor the product CO2 plus and Ni are greatly favored. Okay, now what is happening? This competition for releasing of electrons incidentally remind us of the competition for the release of proton among the acid. The similarity suggests that we might develop a table in which metals and their ions are listed on the basis of their tendency to release electron, just as we do in the case of acid, to indicate the strength of the acid. Okay, what the point here is, student? This competition of releasing of electron incidentally remind us that the competition for the release of proton among the acid. The similarity suggests that we might develop a table which metals and their ions are listed on the basis of their tendency to release electron, just as we do in case of acid, indicate the strength of. So we are going to develop what, student? Electrochemical series on the basis of the releasing the electron. Now second point, what they are saying, as a matter of fact, we have already made certain comparison. By the comparison we have come to know that zinc releases electron to copper and copper releases electron to silver, and therefore the electron releasing tendency of the metal is in the order zinc, copper, silver. We would love to make our list more vast and design a metal activity series or electrochemical series. The competition for electrons between various metals help us to design a class of cells named as galvanic cell, okay, in which the chemical reactions become the source of electrical energy. We would study more about these cells in the class 12. So this is what is the competitive electron transfer reaction, students. I hope little bit it will be okay, because the book is not that way, diagrams are not visible, that I am not explaining, but you can go through it. Thank you so much for watching, friends.